Typically when you have a parabola, actually not typically, all the time, it should be making some sort of U shape. We know that we've got a parabola because the highest term here is an x squared term. So that means that our parabola should be looking like this or looking like this. The way we can tell that it's either a U or an upside down U is going to be by the coefficient of the x squared. Since that's positive, it should look like this one here. And we're going to have to sometimes find a number of things to go along with this graph so that when we graph it, we kind of get a complete picture. So oftentimes we're asked to find the vertex, axis of symmetry, the y-intercept, the x-intercepts, and decide whether the parabola has a minimum or a maximum value. And actually, we can answer this bottom question right now. If we know that this parabola opens upwards, we know that the vertex, which is always kind of that little dot at the bottom or top of the U, if it's opening upwards, this is going to be a minimum value because that'll be the lowest point on the parabola. If it was a downward facing one, it would be the highest point, so it would be the maximum. So the parabola here would have a minimum. But let's kind of start going in order here. So let's find the vertex first. It's always a good place to start when you're graphing these. And to find the vertex of any parabola, we're going to need to use this negative b over 2a formula if it's in this form. So what I'm going to do is just label the a, the b, and the c. So the a is always the number in front of the quadratic term, the b is in front of the linear term, and the c is the constant term. So in this case, if we plug this in, we'll have that the x-coordinate of the vertex is equal to -4, so negative 4, I'm sorry, so the opposite of -4, all over 2 times 1. And the opposite of a negative number is positive. 2 times 1 is also just 2. If we divide that, we get 2. Now, since the vertex is an ordered pair, all we've found here is that the x-coordinate of the vertex is 2. We need to, since this is a point somewhere on the graph, I also need to find the y-coordinate. So to do that, all I have to do is take the 2 and plug it back into that original function here. So if we take this, we'll get y equals 2 squared minus 4 times 2 minus 5. So if we plug all this in, we'll get y equals 4 minus 8 minus 5. And if I simplify all this stuff, this should be giving me, I think, -9 here. So that means my vertex should be at the point 2, -9. I'm going to plot that on the graph right now. So 2, 1, 2, 3, 4, 5, 6, 7, 8. And you know what? I'm 1 point below the graph, but that's no problem. We'll make do. So 2, -9 should be down there somewhere. And now we'll look at the axis of symmetry here next. We know that the axis of symmetry is an invisible line that kind of divides the parabola in half. Okay, it means you could fold the parabola across that line and it would be symmetrical. It would fold right on top of itself. So this axis of symmetry here, this invisible line that goes through the parabola, is going to be at a vertical line, so it should always be at x equals something. So it's a vertical line should have the form of a vertical line, x equals some number. And in this case, the vertical line would have to be at 2. So x equals 2 will be the axis of symmetry. Okay? To find the y-intercept of a parabola, just like when we find the y-intercept of anything, we're going to plug in 0. 0 for x. So to find the y-intercept of any graph, we're just going to plug in 0 for the x. So if we look back here at this parabola, to find our y-intercept, we've got to take this as y is equal to 0 squared minus 4 times 0 minus 5. And you might be noticing that that's just going to be the c term here, that constant term at the end. So in this case, the y-coordinate should be at 0, -5. Okay, so now let's plot this y-intercept on our graph. So this would be the y-intercept at 0, -5 will be right here. 1, 2, 3, 4, 5. So again, we can, if this is the vertex, we can kind of start to see that our parabola is starting to take shape here now that we've got the y-intercept. Now this next point isn't mandatory. It's not something that we're asked for here, but it's a helpful point to get on the graph using the axis of symmetry. It'll also kind of help us see the shape of the parabola. If you notice, if you were to take this graph over 2 points on the right of the axis of symmetry, we could get another point over here because it's symmetric about that invisible kind of vertical line that goes through the vertex. So we also know that it goes through there. So we can start to see the U shape. We're just going to get a few more points. We're going to get the zeros or the X-intercepts. So last but not least here, to find the X-intercepts, what we're going to do, we've got a few options. If you hate factoring, you can go up to this guy. So sorry, we should preface by saying that we're going to plug in 0 for y. So we're going to plug the 0, let's fix that a little bit, plug in 0 for the y. So if we plug in the 0, that will change this equation to 0 is equal to x squared minus 4x minus 5. So there's a few options. Again, if you want to think about this as your A, your B, and your C, if you really don't like factoring, you can use this guy up here, the quadratic formula. This one's set up pretty nicely to factor, though, so I'm going to actually go ahead and factor this. So if it won't factor to, again, you kind of don't have a choice. You have to use your quadratic formula. But I'm going to factor this into, we'll take the factors of 5, so it'll be x and x. Since that last sign is minus, that means the signs have to be different signs. And things that multiply to give me 5, well, there's only one option. It's 5 times 1. And since the 4 is negative, they need to add to -4. So let's make the 5 negative and the 1 positive. So now if we solve this, if we set each piece equal to 0, I'll have x minus 5 equals 0 and x plus 1 equals 0. So I get that x is equal to positive 5 and x is equal to -1. So to write these as ordered pairs now for x-intercepts, I've got one x-intercept at 5, 0, and I've got another x-intercept at -1, 0. So what I'm going to do is just plug this in on my graph. 5, 0, 1, 2, 3, 4, 5 will be right here. And the other intercept should be just the same distance on the other side of the axis of symmetry. So let's check. If we go 3 to the left, 1, 2, 3, yeah, that does put us at -1 for that x-intercept. So we should always just make sure that those are kind of symmetric about the axis of symmetry if it's a nice even number. And now you can see the shape of the parabola. Now that we've found the vertex, the axis of symmetry, the y-intercept, the x-intercepts, and we've discovered that this is a minimum value because it's the bottom, we can actually draw this parabola in here, which I'll do right now. And there's your shape. So there's your U shape going on for that parabola. If you don't have to find the x and the y-intercepts, then one thing you could do is you could just find the vertex and pick, 2 points on either side of the vertex. So you could pick, if I wanted to pick a point, I could pick, since my vertex is at 2, I could plug in, if you make a little chart here, since 2 is your vertex, and we found that was at -9, we could just pick maybe 3 and 4. Those would be 2 points to the right. And then we could also pick 2 points to the left. I could pick 1 and 0, and I could kind of see what's going on there. So if you don't have to find the x-intercept, the y-intercept, and you just have to sketch it, picking 2 points on either side of the vertex is also not a bad idea to graph that. But again, that's a little introduction for how to graph the parabola and find different things on it. Hopefully this video helped you out.